So, here's the first problem. Electric bills in a particular city have a mean of $167 a month and a standard deviation of $23 a month. Find the probability that a random sample of 49 people have a mean electric bill that is less than $160. So we're not talking about one person's electric bill, we're talking about 49 people drawn from the town at random. I take 49 people, I say, what's your electric bill last month? What's your electric bill last month? What's your electric bill last month? And then I find the mean out of all of those people. What's the probability that it is less than $160? Well, we're going to use the new Z formula. X bar minus mu, standard deviation, square root of n. What's this going to be? Right, the sample mean. This is the population mean. 23 is the standard deviation, 49 is the number of people. Here's a trick. These two numbers should be pretty close together. And n has to be a whole number. It can't be a decimal. If you're typing it into your calculator, you probably want to do it like this, with parentheses. 160 minus 167 in parentheses divided by parentheses 23 divided by the square root of 49. Yes, that's a fraction inside of a fraction. And it should work out to negative 3.04. If it didn't, make sure you were, dividing and not multiplying, maybe. So, stop and mess with your calculator until you get that right. Moving on. Once you have your Z value, you need to look it up on the table. And negative 3.04 corresponds to a table value of 0.0012. Because the problem said less than, the table value is your final answer. So, 160, 167, not very far apart. But for a random sample of 49 people, the sample mean should be very close to the population mean. Okay, let's try another example. More about men's heights. Assume the mean height of men in a particular region is 68.3 inches, and the standard deviation is 2.9 inches. What is the probability that a random sample of 85 men has a mean height greater than 69 inches? Once again, you're going to use the new Z formula. (69) is our X bar, the mean height of the random sample. 68 is the mean height of the whole population. 2.9 is the standard deviation. 85 is the number of men that you asked. Once again, these two numbers are pretty close together. This is a whole number. Should work out to 2.23. If your last digit isn't right, you might have rounded your square root too much. Try to enter it as a single line without any internal rounding. If you have to round inside, like if you have to write it down, keep at least 4 decimal places. So you can wind up with 2 decimal places of accuracy in the end. Okay, we found z. What do we do after we find z? Yep, the table. The table value is 0.9871. Is that the final answer? No. It said greater than. So to find the final answer, we need to do 1 minus the table value. 0.0129, about a 1% chance. Wow. So a random sample of 85 men, their sample mean is going to stick really close to the true population mean. We good? Good. Let's try another example. This one's a little trickier. We want to know how many people can you fit on this boat safely. We have determined that we can only put 2,500 pounds on the boat. And we're going to assume that the mean weight of American adults is 176 pounds with a standard deviation of 42 pounds. How many people can we put on the boat? What? We can't use the z formula for that. No, we can't. Because we got to do some other work first. Well, the first thing I would do is divide. If we got a whole bunch of people who are 176 pounds, how many can we fit on that boat? Well, the maximum weight divided by 176 pounds per person is 14.2. So that suggests that 14 people should be safe on this boat. But what if some of the people are heavier than average? Could that happen? Sure. How likely is it? What is the probability that if we put 14 people on the boat, they're going to be overweight? That's the real question. So, if the total weight of the 14 passengers is 2,500 pounds, their sample mean is going to be 2,500 divided by 14, 178.6 pounds. So, we keep having to restate the question. Why? Because this question is complicated. So, what is the probability that a random sample of 14 adults has a mean weight greater than 178.6 pounds? Now we've managed to restate the question to sound more like something that we can use the formula for. So you plug your numbers into the z formula. Once again, these are pretty close together, and your sample size is a whole number. So we get z equals 0.23. Once again, take it to the table. Table value, 0.5910. Is that your final answer? No. Greater than 1 minus 0.5910 is 0.4090. That's the probability that the boat will be overweight, about a 41% chance. Do you want to ride on a boat that has a 41% chance of being unsafe? I don't. I really do not want to get on this boat that has a 41% chance of being unsafe. So we should definitely not let 14 people on the boat, unless they're all like little kids or something. So, would the boat be safer with 13 people? Probably. How about 10? We can repeat the calculation with 13 people, 10 people. Remember, 13 people would have a bigger sample mean because we'd have to go back to this. Which would change this to 13 and this to something bigger. So you find the probability that the boat is too heavy with each of those numbers. And then, decide whether you're comfortable. It's never going to be 0. The risk is never going to be 0. But, would 1% be small enough? Would you like it to be smaller?